All right, so in this video, we're going to go through sample question 18 from the Society of Actuaries ExamP list of sample questions. So the question reads, two instruments are used to measure the height h of a tower. The error made by the less accurate instrument is normally distributed with mean 0 and standard deviation 0.0056h. The error made by the more accurate instrument is normally distributed with mean 0 and standard deviation 0.0044h. The errors from the two instruments are independent of each other. Calculate the probability that the average value of the two measurements is within 0.005h of the height of the tower. All right, so now this is a great problem to illustrate how to work with a normal distribution. All right. At this point, I'm going to just assume you're familiar with continuous versus discrete distributions. If I were to go into that in depth, and I'm going to also assume you're familiar with what the normal distribution is. If I were to talk too much about that, this video would be longer than anybody would want. So if you want me to make a separate video just talking about those topics and talking about the normal distribution, just let me know in the comments. But the normal distribution is the most common distribution you will get on ExamP, and it's arguably the most important and just very common, like just the most popularly used in a variety of fields of data science, right? So let's look at what this question actually gives us. So it says two separate instruments, which I'll just say x1 and x2. And it says the less accurate instrument, x1, has a normal distribution with mean 0, standard deviation 0.0056h. So x1, the mu of x1 is equal to 0, and the standard deviation if x1 is equal to 0.0056h. Okay, and then x2, right, the more accurate instrument, has the same mu value, different sigma value. So mean is 0, and standard deviation is 0.0044h. And then it tells us the errors from the two instruments are independent of each other. We're asked to calculate that the probability that the average value of the two measurements is within 0.005h height of the tower. Okay. Now, the fact that the two instruments are independent of each other is very important, especially when we're talking about normal distributions. The sum of independent normal distributions is also normal. All right. So because it's asking about, and I'll denote this as y, it's asking about the average of the two measurements, right? It's asking about the probability that x1 plus x2 over 2 is within some range. We want to get the mu value and the sigma value of both of this, which I'll be denoting as y from this point onward. Okay, a lot of standard distribution questions can just boil down to get me the expected value, right, and also get me the standard deviation, and then you can go anywhere you want from there. So what is the mean of y? Well, the mean of y should be the sum of each independent thing. So the expected value of y is equal to the expected value of x1 plus x2 over 2. And I'm really assuming you're familiar with how to deal with expected value, right? You should know how to do this before you even get to the point of learning about different probability distributions. So I'm going to take out the constant 1/2 to the front, and then do the expected value of x1 plus expected value of x2. Now, I know for a lot of you this might seem very obvious what the answer is without even having to do any of this, but I just want to be thorough in my explanation. So you don't know how to do it with just this problem, but you know how to do it with every problem, right? Sorry, this should go here. And then 1/2 times 0 plus 0, which of course equals 0. And that is the mu of y. Now let's look at getting the standard deviation. So the way the way we could sum the expected values, the means, we can't do the same thing with standard deviation because the relationship works with variances, and that's super important to know, right? So the sum of independent normals is also normal, so the new variance is equal to the sum of the previous variances. So if I were to calculate the variance of y, and then using the variance we'll get the standard deviation. So here, variance of y, that is equal to the variance of x1 plus x2 over 2. Now, when you take out a constant for your variance, you have to square it. So this is going to be 1/2 squared, which is 1 over 4, times the variance of x1 plus x2. And then I'm allowed to split these up. So 1 over 4 is equal to the variance of x1 plus the variance of x2. Now, the variance of x1 and x2 should be its standard deviation squared, right? So the variance of x1 is 0.0056h squared. Variance of x2 is 0.004h squared. So I'm just going to plug that into a calculator to get the final answer. So 0.0056 squared, right? Yeah, 0.0056 squared plus 0.0044 squared multiplied by 1 over 4 gets me quite a small number of the variance of y equaling 0.00001268. And then in order to get the standard deviation, I square root the variance. So I get the standard deviation, SD of y, or sigma sub y, is equal to 0.00356. Okay, now these are the two important pieces of information we needed to kind of solve the problem. So at this point, it should be fairly easy. What is the question asking us? The question is ultimately asking us the probability that y falls into a certain range. And that range is 0.005h. So you're either 0.005h below, so that would be negative, below from the average, and the average is 0. So you're either at negative 0.005h, less than or equal to y, less than or equal to positive 0.005h. Okay? Now, what do we do from here to actually get the probability? We need to normalize it, right? Standardize it. We can kind of do something called getting a z-score or getting a standard score in order to use the table given to us that represents the area under the standardized normal distribution. Okay? What that basically means is you have a normal distribution, you get a z-score, and you're able to use a table to match up that z-score to a specific probability. So let's get that z-score. How do we get it? Well, the z-score, sometimes also represented as phi, right, of whatever the number is, is equal to the random variable minus mu, minus the mean, divided by the standard deviation. Very important formula to know by heart. I can't stress that enough. So we perform this operation to each part of this inequality. So this becomes negative 0.005 h minus 0 divided by the standard deviation of 0.00356, less than or equal to, I'm just going to now write z less than or equal to 0.005 h minus 0 over 0.00356. And let me calculate that for each of them. 0.005. Oh, right, sorry. I should kind of missed one thing. The variance is this number times h squared, so this is the standard deviation. So these should also be here. Small detail, but important. So doing that division gets me the following z-scores. Which is 1.4041, which since our table goes to 2 decimal places, I'm going to just round. Sorry, and this would be a negative. Less than or equal to z, less than or equal to positive 1.4041. Okay, so what does this mean? This is essentially telling us that the area we're looking for on the standard normal distribution is in between our z values, where let's say this is a z value of 0, is in between negative 1.40, I'm going to round down to negative 1.4, and then positive 1.4. Okay, so what the table does is it represents the area under the standard normal from negative infinity up to this value. So it gets us a CDF. And what we're going to do is, since there is no way to like directly get the area in between here, what we're actually doing is, let me see if I can illustrate this with different colors. In order to get that, first we calculate the area, the CDF of 1.4, so the area under here. And then we calculate this, right? This value is on the table, so it's not actually calculating it, we're just looking up the actual area here. And then we take this area away from this whole thing with a subtraction, and what we're left with is the area between here, which represents the probability of falling in that range. Hopefully that made sense, right? So let's go about actually looking this up. We need to find phi of 1.4 and then phi of negative 1.4. So phi of 1.4, pretty easy to get. That is just straight. I don't actually have it printed out. I just pulled it up on my computer. This is I'll have a link to this in the description. However, if you also just look up ExamP normal table, it should be like the first link, right? So here, I don't know if that comes up clearly. I go to 1.4, 0. So the value of that is 0.9192. So the area under the curve all the way up to 1.4 is 0.9192. But I'm not looking for just the probability that I'm less than or equal to 1.4. I'm looking for between two spots. So I need the z-score of that in order to kind of subtract that away. The issue you might see is that negative values aren't on the table. So how do we go about actually finding that? So this explanation, I don't want to go too heavy into it, so it will be a oversimplification. However, I don't want to not mention it at all. So since the normal distribution is symmetric at 0, 50% of the area is on this side, 50% of the area is on that side, right? And let's say you're looking for the z value. We're looking for the z value 1.4, so or negative 1.4. There is actually there's an equal amount of area on this part of the graph as there is on this part of the graph, right? The area under the curve from negative infinity up to negative 1.4 is equal to the area from 1.4 up to positive infinity. We can use that to our advantage, all right? On top of the fact that the area under the normal distribution is a probability, so the total area should be equal to 1. So if we have the CDF from negative infinity up to 1.4 and subtract by 1, right, taking this away, we should be left with everything greater than 1.4, which should be the same as the area from negative infinity up to negative 1.4. Simply put, if we have something like this, if we need to get the z-score of a negative, if we have to find the CDF of a negative value using the normal table, we simply make this substitution. This is 1 minus phi of positive 1.4. Hopefully that explanation wasn't too weird, but this is why that substitution works. So here we do 1 minus phi of 1.4, which we already got in our previous step. So I just do 1 minus 0.9192, and I get 0.0808. And then I simply subtract, right? The area of this minus the area of this gets me the area in between the range that I'm looking for. So that's going to be 0.9192 minus the result from our previous step, and I get a final answer of 0.8384. Okay? So all in all, not too complicated of a question. My explanation might have just been a bit longer just because normal distribution is quite important. Oh yes, and that matches up with answer choice D there. But yeah, I can't stress how important it is to know the normal distribution. Be familiar with using that table for normal distributions. and understanding how to calculate a z-score and to use independent normal distributions to get a new distribution, right? The sum of independent normals is itself independent. So that pretty much covers question 18. If there were any questions, anything you want me to clarify, anything you think I could explain better with something like this, leave it down in the comments. I'll respond to whatever questions you have. If you want to check out another video on an example ExamP problem, I have a playlist. But other than that, good luck, guys.